Chem Mastery, your study buddies.
Hi everyone. So in the last video, we discussed on the rate of reaction and we gave 3 tutorial questions for you to answer. So in this video, we will go through each of the tutorial questions given. Okay, so for the first question, define the rate of reaction, the frequency of collision, and the frequency of effective collisions. And here are the answers for the rate of reaction. It is the changes in the quantity of the reactant per unit time, or the changes in the quantity of product per unit time. So it is how fast a reaction occurs. The units can be in gram per second for the change in mass over time, molar per second for the change in concentration over time, or centimeter cube per second for the change in volume over time. And as for the frequency of collision, it is how often the reacting particles collide with each other without considering if they have the correct orientation. So as I have explained before, the reacting particles can collide with each other even if they don't have the correct orientation. But if they don't have the correct orientation, they will not be able to form a bond. The frequency of effective collision, on the other hand, is how often the reacting particles collide with each other in the correct orientation so they can form a bond. Moving on to our second question. So, the experiment was carried out using magnesium ribbon of same length to react with acids as shown below. First experiment, we have the 150 ml of 1 molar hydrochloric acid. The second experiment, we have 100 ml of 1 molar sulfuric acid. And then we have to determine which experiment has a higher rate of reaction, and we also need to include the calculation and sketch the graph. So first of all, what we do is we write the overall reaction of both experiments. So for experiment 1, here we have magnesium reacting with hydrogen chloride to form magnesium chloride and hydrogen gas. And for experiment 2, we have magnesium reacting with sulfuric acid to form magnesium sulfate and hydrogen gas. So we need to find the concentration of hydrogen ions for both of these experiments, because hydrogen chloride will break down into hydrogen ions and chloride ions, while sulfuric acid will break down into hydrogen ions and sulfate. And so they are the reacting particles, which is why we have these two equations here. So for the first experiment, we calculate the mole of HCl, where we have the molar already and the volume, so we just multiply them to get 0.15 mole. This 1 mole of HCl produces 1 mole of hydrogen ion. So that means the mole of hydrogen ion is also 0.15 mole. Then we calculate its concentration, where we just divide the mole of hydrogen ions by the volume, which was 150 ml. But we convert it to liter first, so we divide by 1000, and we will end up with 1 mole per liter of hydrogen ions. Then we look back to our overall rate of reaction. The magnesium reacting with hydrogen chloride, producing magnesium chloride and hydrogen gas here. We can see that 2 moles of hydrogen chloride will produce 1 mole of hydrogen gas. So that means if we have 0.15 mole of this HCl, then we'll only get half of this number, which is 0.075 mole of hydrogen gas. So it's written here 0.075 mole. Since we want to calculate the volume at STP, we multiply this 0.075 mole by 22.4 and we get 1.68 liters. The volume we calculated here will be used in the graph, which will be shown in the next slide. Similarly, for experiment 2, sulfuric acid will break down into hydrogen ions and sulfate. And again, we calculate the mole for the sulfuric acid, where 1 molar times 100 divided by 1000, we get 0.1 mole. And because 1 mole of sulfuric acid produces 2 moles of hydrogen ions, that means to get the mole of hydrogen ions, we multiply 0.1 mole by 2, and so we get 0.2 mole of hydrogen ions. And the same as the first experiment, we calculate the concentration where we will get 2 mole per liter, and then we look back on the overall rate of reaction, where 1 mole of sulfuric acid produces 1 mole of hydrogen gas, so that means the mole of hydrogen is also 0.1 mole. Then we calculate the volume for our graph, and we get 2.24 liters. So by calculating the concentration of hydrogen ions of these two experiments, we can see that the concentration of hydrogen ions is higher in the second experiment, where we have 2 moles per liter, while the concentration of hydrogen ion in experiment 1 is only 1 mole per liter. So that means experiment 2 has a higher rate of reaction. Here are the graphs for experiment 1 and experiment 2, where we can see that the volume of gas we calculated was 1.68 liters for experiment 1 and 2.24 liters for experiment 2. And since the graph is in milliliters, we multiplied them by 1000 and we get 1680 ml and 2240 ml. We determined that the second experiment has a higher rate of reaction, which is why the line is more steeper. That shows more gas were produced in a less amount of time compared to experiment 1, where it is less steeper, and this shows that the second experiment has a greater initial rate of reaction. And since the question asked to sketch the graph in this graph, the spacing is not important. But if it is asked to draw a graph, then make sure that you draw the graph using a graph paper or with proper spacing. Okay, so I hope you understand question 2. So now let's move on to our third question. An excess amount of granulated zinc is added to 100 ml of 0.5 molar hydrochloric acid. The gas liberated is collected at intervals of 30 seconds. A graph of volume against time is shown by the curve X at STP. Now we have to state 3 different ways to obtain the curve y for each graph. Then sketch a graph of the volume against time if the acid is replaced with sulfuric acid with the same volume and molarity. And then we need to show the volume of gas. Then we calculate the value of alpha and beta. Explain the effect rate of reaction if the experiment is carried out using 100 ml of 0.25 molar sulfuric acid. And why does the reaction stop at beta volume of gas? So for the first graph, what we can do is we reduce the volume of the 100 ml 0.5 molar hydrochloric acid to 50 ml. So why do we reduce this volume? It is because in the first graph, we can see that the curve y produce less product. So if we reduce the volume of the HCl we use, that would mean less moles will be present in the reactant, and less mole of the reactant, the hydrogen produced will also be less. Then we can also use zinc powder instead of the granulated zinc, and also use high temperature to increase the rate, as the initial rate of curve y is slightly higher than curve x. For our second graph, curve y has a higher initial rate but produce the same amount of product as curve x. So we can increase the rate by using zinc powder instead of granulated zinc, using high temperature, and we can add a catalyst to speed up our reaction. So for the second part, we have to draw a graph if we use sulfuric acid instead of hydrochloric acid. So first of all, we write down the equation where we have zinc reacting with sulfuric acid to form zinc sulfate and hydrogen gas. Then we calculate the mole of sulfuric acid, where the molarity and volume is the same as the hydrochloric acid, so we just multiply that and we get 0.05 mole of sulfuric acid. And from the equation, we can see that 1 mole of sulfuric acid produces 1 mole of hydrogen gas. So if we have 0.05 mole of sulfuric acid, we will have 0.05 mole of hydrogen gas. And since the reaction is carried on in STP, so to get a volume of the hydrogen gas, again we multiply the mole of hydrogen gas by 22.4 liter per mole, and so we get 1120 ml of hydrogen gas. Then we can construct the graph here, where you can see that the volume of gas form is 1120 ml. Moving on to the third part, we have to calculate the value of alpha and beta. So first, we write down the overall reaction for zinc, reacted with hydrogen chloride to form the zinc chloride and hydrogen gas. Then we calculate the mole of hydrogen chloride and we get 0.05 mole. And since from the equation 2 mole of HCl produce 1 mole of hydrogen gas, this means that the mole of hydrogen gas produced is half the mole of HCl, which is 0.025 mole. Then we can find beta by multiplying the mole of hydrogen gas by 22.4 liter per mole. And since it is an STP, and then we can get 0.56 liters. And since the curve X is the same for both graphs, we know that the volume of since the curve X is the same for both graphs, then beta is equals to 2 alpha. And since we already know beta, we can find alpha, which is 0.28 liters converted into milliliters is 280 milliliters. Okay, now let's look into part 4, where we have to explain the effect rate of reaction if the experiment is carried out using 100 ml of 0.25 molar sulfuric acid. So how we do this is similar to the calculations in question 2, where we find the concentration of the hydrogen ions. So in here we calculate the mole of HCl, which is 0.025, and because we calculate the mole of HCl, which is 0.05, and because the mole ratio is 1:1, so we have 0.05 mole of hydrogen ions, and then we calculate the concentration to get 0.5 mole per liter. Same thing for the sulfuric acid, we find its mole, which is 0.025, and because the mole ratio here is 1:2, the mole of hydrogen ions will have to be multiplied by 2, so we get 0.05 mole. And then we calculate the concentration, which is 0.5 mole per liter. Then, by comparing these two concentrations, we found that the concentration of hydrogen ions, when using 100 0.5 molar of HCl and 100 ml 0.25 molar sulfuric acid are the same. Therefore, there is no difference in the rate of reaction. And as for the last part, why does the reaction stop at beta volume of gas? It is because the reactants have finished reacting with each other. That means no more reactant particles are available to form bonds, so no more hydrogen gas is produced. That's why in the graph it just shows constant volume. Alright, that is all for the discussion of the tutorial questions, and I hope you can understand my explanation. Thank you very much.